in line with our Syllabus 2.2 Meteorological Information. E-Plan 6, Meteorological, Ship Safety and Operation using IMO SMCP. Let's talk about marine weather forecasting and shipboard equipments or devices that provides information, weather warnings and forecasts relevant to vessels within specified coastal areas. The importance of using marine weather forecasting. The information provided by marine weather forecasting agencies is essential for preventing accidents by avoiding storms and other weather-related hazards. The system provides navigational safety information, weather warnings, and forecasts relevant to vessels within specified coastal areas. The borders of the oceans are the limits of Earth's oceanic waters. The definition and number of oceans can vary depending on the adopted criteria. The principal divisions, in descending order of area, of the 5 oceans are the Pacific Ocean, Atlantic Ocean, Indian Ocean, Southern Antarctic Ocean, and Arctic Ocean. Smaller regions of the oceans are called seas, gulfs, bays, straits, and other terms. Geologically, an ocean is an area of oceanic crust covered by water. What are specific geographic areas? A specific geographical area refers to a defined location or region on Earth with distinct boundaries, such as a city, country, continent, or any other demarcated area. It is essential for studying various aspects of human geography. What is Inmarsat-C? Inmarsat-C is a two-way data messaging system that enables users to transmit and receive messages to and from other ship Earth stations, as well as telex and data subscribers anywhere in the world. Inmarsat-C does not provide voice communications. The Inmarsat-C service operates on a store and forward basis. Inmarsat-C Weather Bulletin comes in many form and format, but it has one thing in common. It provides weather information.
Okay. So sa weather bulletin natin, yung ating weather bulletin, merong 6 na bahagi yan. Siya nga pala guys, meron tayo nitong libro na to ito. So magandang pag-aralan yan. Basa-basahin kasi marami tayong matutunan din na information. Sa yung weather bulletin natin, merong 6 na bahagi o 6 na parte. So ito yung itsura ng weather bulletin natin. Ngayon, yung unang bahagi dyan, yung storm warnings. Kasi medyo importante yan. Nasa una yan. Tapos, pangalawa, yung synopsis, yung general assessment, general condition dyan sa mga area na yan or sa area na yan. Then, yung forecast, saka prognosis, yan halos magkaparehal yan. Yung prediction ng weather. So, itong nasa 5 or 6, optional na yan. Yung hindi mo na, yung minsan na, hindi mo na makita yan. So, dito tayo. Ngayon, ito si John, pag-practice natin, pahanapin natin ng saan banda yung dyan.
Yes, sir.
So, yung weather report natin, ayan, may oras yan, yung UTC, anong petsa siya dumating, then yung validity. Kailan valid itong report na to? Ang weather bulletin pala guys, required yan at least every twice a day ang transmission yan, ang reporting. So, yung karamihan sa mga area, every 12 hours, meron sa umaga, meron sa gabi. So, ang validity niya, pitsadjes hanggang bukas. Pitsadjes ng
July
alas 8 ng gabi hanggang bukas ng alas 8 ng umaga. Tapos bukas, magsisend naman ulit sila ng update, panibagong update. So, saan yung coverage niya? Ito, coastal line, 200 nautical miles. So, mostly ang makita mo sa report na to, yung banda lang dito sa coastal area. May hiwalay sila na report dito sa oceanic area. So, mamaya, pakita natin. Okay? Saan yung number 1 dun? So, ano ulit yung number 1? Storm warning,
Storm
diba?
warning, sir.
So, nakalagay dyan, special warning.
Sir.
Special warning of severe severe or weather or gale. So merong masamang panahon. Saan banda?
Severe.
Corona Lighthouse to San Pedro Lighthouse area. So saan banda yan? Medyo malayo-layo sa atin yan. So yan ang i-locate mo. Saan banda yung San Pedro Lighthouse na yan? Then oceanic area, Huasco to Constitucion. So yan yung kung may mga storm warning sa nav area na kinapapasukan mo, yan yung bumuntayan din. Then pangalawa, yung synopsis. Synoptic situation. O yung general condition sa nav area na yan. Then meron daw yan. Ano sabi na?
Zones 1 and 2, Arica to Valparaiso.
So, yan, general condition nila, parang summary. Yan. Then yung, ito sa number 3, dito yung tutukan natin, yung forecast na number 3. So, saan ulit na solve tayo dun?
Zone 2 and 3,
diba? So, yun ang hanapin mo. Saan yung zone 2 and 3?
Ito, sir.
So, meron zone 1 dyan.
Zone 2.
Tapos,
Tsaka zone 3.
Anong sabi ng ano dyan? Ng weather forecast dyan?
Zone 2, sir. From Coquimbo to Valparaiso.
So, anong weather condition meron tayo?
Clear to scattered, 10 kilometers. Wind southwest.
Anong ibig sabihin ng clear to scattered? Yan, may mga ulan-ulan or mayroong clear visibility or scattered rain showers. Ano yan? So, 10 kilometers visibility. Then, yung hangin,
South or southwest.
South to southwest. Ang speed, 35 to 25 knots. Then sea state, very rough. So,
rough.
Meron tayong ideya dyan kung saan yung direksyon ng hangin. Swell, meron swell. Kasi merong banda doon sa area na to, merong storm. So, yung galaw ng dagat doon, umabot dito sa area na to. Kaya magkakaroon tayo ng swell. Southwest in oceanic area. So, karamihan dyan, pinapaigsi. May mga terms dyan na mga sino-shortcut. So, aralan natin yan. Nasa libro yan. Yung mga abbreviations, anong ibig sabihin ng mga mga terms, weather terms na ginagamit nila dyan. Okay, so
how Navtex works. The Navtex works on a frequency of 518 kHz in the medium frequency band. 490 kHz frequency is also used by some countries for broadcasts in the national languages, also known as national Navtex. Where medium frequency reception is difficult, transmissions are made on 4209.5 kHz. The default setting in a Navtex is 518 kHz. The entire world is divided into 21 areas known as Navaries, including 5 areas recently introduced for the Arctic region, for the purpose of distributing this information. Each Navaria has multiple Navtex stations which further helps in transmitting the messages. The format of the message. The message in a Navtex receiver appears in the following format. ZCZC B1 B2 B3 B4 main message NNNN. ZCZC, it is the start code. It indicates the beginning of the message. B1, this character represents the station ID. B2, this character is called the subject indicator. It is used to represent the type of message. A to Z. The characters B1 and B2 are used by the Navtex receivers to reject messages from stations of concerning subjects of no interest to the officer. B3 and B4. B3 and B4 is a 2-digit serial number for each message. NNNN. This indicates the end of the message. The characters B3 and B4 are used by receivers to keep already received message from being repeated. Below is an example of a message. ZCZC 0820. WZ 1593. Scotland, West Coast. The North Cardinal Light Buoy 58.01.2 and 005.27.1 W. have been permanently withdrawn. Cancel WZ 1562. NNNN. Types of messages. The NAVTEX receives the following kind of messages. A equals navigational warning. B equals meteorological warning. C equals ice report. D equals search and rescue information / piracy and armed robbery. E equals meteorological forecast. F equals pilot messages. G equals ACE messages, formerly DECA messages. H equals Lawrence C messages. I equals Omega messages. J equals SatNav messages, GPS or GLONASS. K equals other electronic navigational aid system messages. L equals navigational warnings, additional. M to U equals reserve. V equals notice to fishermen. W to Y equals reserve. Z equals no messages on hand. The NAVTEX receiver can be set to ignore certain types of messages, however, messages A, B, D, and L because of their importance cannot be rejected by navigating officers. Audible alarms can also be generated when message type A, B, D, or L is received. It should only be possible to reset this alarm manually. We should also note that when programming the type of messages to receive, it is wise to ensure that only those which are required and necessary are programmed for the reception. Otherwise, a good deal of paper will be wasted or one will have to scroll through a mass of messages if the broadcasts are received in soft copy.
What is the purpose of the weather facsimile? A device used to receive weather reports. Each ship is provided with a weather fax receiver with a printing facility, which enables weather patterns showing isobars and barometric pressures to be printed at regular intervals. The weather map is a symbolic representation of the atmospheric conditions of an area at a given time. On a weather map, you will find isobars and symbols related to pressure, direction, and velocity of winds, clouds, precipitation, and sea condition on a base map with political boundaries. These details are recorded at different weather stations at specified time. Meteorological departments forecast weather conditions by evaluating these weather elements shown on a weather map. This weather map is used in predicting weather conditions for a day, a week, or a month in advance, which helps in taking precautions and safety measures. Weather forecasts help farmers, fishermen, and crew of ships. It also helps air flights in predicting atmospheric conditions ahead. Weather maps are the collection of weather information from various meteorological stations pertaining to the particular map area. Temperature degrees Fahrenheit, present weather, visibility in miles, dew point in Fahrenheit, wind speed in knots, wind direction from southwest, amount of cloud cover in percentage, barometric pressure in millibars 1019.6 MB, barometric trend, a steady 1.9 MB rise the past 3 hours, precipitation inches past 6 hours.
Weather station models. What exactly is a weather station model? Well, we know in the study of meteorology that there's lots and lots of information to look at. Everything from visibility to humidity to temperature. And communicating all this information can be very tricky, especially considering it's changing on a minute-to-minute basis. And so, meteorologists have devised a system of codes and numbers that can take large amounts of data and simplify them to make it easier to communicate. And that's what a station model is. Here's what a station model looks like. Now, you may have seen these on weather maps. We need to be able to interpret these, that is, know exactly the conditions that this station model is revealing. And so what we're going to do is we're going to look at all the numbers and symbols on this and figure out what exactly it's telling us. So let's get started. We'll begin with the center. The center circle on a station model is going to be colored in to a certain extent, and the amount of coloring reveals the amount of cloud cover. In this case, because 3/4 of the circle are colored in, we know it's a 75% cloud cover. We might call that mostly cloudy. On a clear day, the circle wouldn't be colored in at all. On an overcast day, it would be completely covered in. Typically, we'll refer to the cloud cover as a percentage, as you see here. Next, let's look at this odd kind of symbol down at the bottom. This reveals both the wind speed and the wind direction. And let's see how that works. Let's start with the direction. Imagine we had a plane circle here, the start of a station model. If I have a line looking like this, that's telling me where the wind is coming from. So if you think of this as a compass with the top being north and the bottom being south, the left being west and the right being east, then this would reflect a wind blowing in this direction. We would call it a westerly wind, which is a wind blowing from the west. Keep in mind that when we name winds, we name them for the direction where it's coming from, not where it's blowing to. So this wind, shown on this station model, would be a west wind. If the line were over here, it means it's going in that direction, and we'd call it an east wind. We can also have in-between directions like this. It would be going in this direction, and we would call it a northeast wind. Now again, that means it's coming from the northeast. So if we go back to our station model and look at our wind direction here, we would see that it's coming from the bottom left, which means it's a southwest wind, which means it's coming from the southwest. Now, there's more to talk about with wind than just the direction. We also want to know how fast it's blowing. And to do that, we use a unit called a knot, K-N-O-T, and a knot is very similar to a mile per hour. The way we tell the wind speed is by looking at these two, in this case, two markings down in the end, and we call these feathers. These feathers can either be long or short. As you see here, we have one long one and one short one. Now, for every long feather, we have 10 knots of wind speed. And for every short feather, we have 5 knots of wind speed. So in this example, since we have one long feather and one short feather, our wind speed is 15 knots. If you have an in-between wind speed, 16, 17, 19, 11, things like that, for our purposes, we'll just round to the closest 10 or 5. Back to our station model. Let's look at the numbers now. The number on the top left corner is always going to be your air temperature, and it's always going to be in degrees Fahrenheit, though we never put those units on the station model itself. Remember, the purpose of a station model is to communicate lots of information, but in a small, simple format. And so we don't bother ourselves by including units, we just simply put the numbers. So keep in mind the temperature, which will always be on the top left, and always in degrees Fahrenheit. Okay? Right beneath the temperature, we'll see a number, which in this case is 1/2. That reflects our visibility. And what that means is how far you can see in the distance before your view becomes obscured by cloud cover or the other components of the atmosphere. It's always going to be measured in miles. And so in this case, we have a visibility of 1/2 of a mile. Next to the visibility, there will be some sort of symbol. And the symbol tells you what the present or current weather conditions are, if there are any. Now, in order to figure out what each symbol means, you would need this table, which is found in your Earth Science reference tables. And so if you look, we have different symbols for different things, from drizzle to rain, smog, thunderstorms, haze, etc. Now, the symbol that we see on our station model reflects snow. So that means this location is currently experiencing some snow. What about in the bottom? Well, this number in the bottom left corner is going to be our dew point temperature. In this case, it's 27 degrees Fahrenheit. Just like the air temperature, this is always going to be measured in degrees Fahrenheit. Now, there's one thing I want to point out about that, and that is that the closer together these two numbers, that's going to reflect a higher humidity. And that's important to note because relative humidity is not a number that's included on the station model, though it can be inferred using the temperature and the dew point. So keep in mind, when these numbers are close together, that reflects a higher humidity. If they're farther apart, that means it's less humid. In the case of the example we're looking at here, we can see that it's fairly humid on this day, being that there's only a 1 degree difference between the temperature and the dew point. Moving on, On the bottom right-hand corner, you may see a number, and that's going to reflect the amount of precipitation, rain or snow, that has fallen during the past 6 hours. In our example, there's been 1/4 inch of precipitation. Finally, to the last two numbers. These are going to relate to our air pressure, or our barometric pressure. And these are probably the trickiest numbers to decipher on a station model. Let's begin with the actual pressure, which is the number on top, in this case 196. Now, to measure pressure, we use an instrument called a barometer. It measures barometric pressure, which in essence is the amount that the air is pushing down on you on the surface of the Earth. Now let's go through an example here. A typical pressure measurement, for example, the one we see on this barometer, might be something like 1,014 millibars. Typically on Earth, the pressure is going to range from about 950 millibars up to about 1,030, 1,040 millibars. So 1014 is certainly a typical pressure that you might see on a nice day. The problem is this. This is a big, bulky number. It's got 4 digits, a decimal point, 1 decimal place, and units. And remember, we're trying to save space on our station model. So meteorologists have come up with a system of coding or shortening the air pressure to save space on a station model. Now, if this were my air pressure, here's what I would do to code it. First thing you're always going to do is get rid of the units, because remember, we don't use any units on a station model. So you drop your, in this case, MB, which by the way is millibars. Next, what we're going to do is we're going to drop whatever the number starts with. And you have two choices. It's always going to start with either a 10, like in this case, or a 9. And so whether it's a 10 or a 9, you're going to drop that. So we're going to go ahead and drop our 10. Now the last thing is, we're always going to be going to 1 decimal place, so we don't need to include that decimal point. We know it's there. There's no need to actually waste the space and use it. So let's get rid of that decimal point. And so what we're left with is 140, and that's the number you would actually put onto your station model. You see how it's much shorter than writing 1014.0 millibars. Much simpler. Let me give you one more example of how to code air pressure. Here I have a slightly lower one, so this might occur on a stormy day. 973.2 millibars. Now remember, to code this, we want to shorten it. So I'm going to start by getting rid of my units. Now remember, we said we also have to get rid of what it begins with, which will either be a 10, like in the previous example, or in this case it would be a 9. So we can drop our 9. Then all we have to do is drop our decimal point, and we're left with 732, and that's the number that's going to go on our station model. So if we go back to our example says 196. So we have to figure out what that actually is in the full version. So in this case, instead of shortening, we're lengthening. We want to know what this number is. So we have a very simple rule to convert this. And the rule is this. If the number on the station model is less than 500, then you're going to add a 10 before it. If it's greater than 500, then you're going to add a 9 before it. So our number in this example is 196. And that's certainly less than 500, so we're going to go ahead and add a 10 before it. But don't forget, we also have to add a decimal, which will always be right before the last digit, and a unit on the end, which will always be millibars. So when our station model says 196, we know that that actually means we have an air pressure of 1019.6 millibars. Let's not forget about the final number on our station model. Just beneath the barometric pressure is something called the barometric trend. Now, as we learn about weather, we will see that what the air pressure is doing signifies what's going to happen with the weather. So, for example, when the air pressure is dropping, that's a sign that bad weather is approaching. When it's rising, that's a sign that good weather is approaching. And so knowing what the pressure is doing is very important. And so we include the barometric trend, which is just that. It's a measure of how the pressure has changed in the past 3 hours. So in this case, this plus 19 with the slash going up tells us that the air pressure has increased by 1.9 millibars over the past 3 hours. The reason I know it's increased is because I have this plus sign here. Had the pressure dropped, that would be a negative sign. Another thing is this interesting little graph. Think of it as like a little mini line graph. That's telling you the trend. And so you see that the line is going up. That's a vertical trend. It's an increase. Had the pressure dropped, that line would be tilted downwards, showing you a decrease. And so that's how